So quickly, we are going to divide fractions. And this one's pretty straightforward. I'm gonna do a little animation, my little made up animation. You'll see what I'm talking about. Uh, when we're when we're dividing fractions, what we have to do is this. I'm gonna just make up some fractions right now. If you're doing this, let's see. You have to flip the second fraction, which the correct term is called find the reciprocal. The reciprocal of 1 over 5 is 5 over 1. So you're going to flip it. So we're going to multiply by the reciprocal. Now here's the little animation thing I'm talking about. I'm going to try to do it. So the reciprocal is going to look like this. Same thing as just flipping the fraction. I call it flipping the fraction. So it's almost like we're taking it like this. Literally like this. Boom. And then this division sign changes to multiplication. And then you do the multiplication rule, which is just multiply straight across, right? Just because there's nothing that can be reduced or canceled or cancel each other or anything like that. And so it's going to be a 2 times 5 is going to equal 10. And it's a 3 times 1 is 3. So pretty much that is it. Whenever you're dividing fractions, you're going to flip the second fraction to its reciprocal. That's what it means to be flipped. And then you just multiply straight through. So originally it was this. And then we'd flipped it and multiplied. And we got our answer. That is basically it when it comes to dividing fractions. So let's look at some fractions, some examples. 5 over 3 divided by 7 over 5. Now you may be tempted to, start canceling. You may be tempted, let me cancel this 5 with this 5. But there's no canceling yet. We're going to have to flip and multiply first. So it's going to be, the next step is going to be this. So this is flipped over, see, we see it flipped, and then this sign has changed to that. Now we can look to see anything that can be reduced, canceled each other, anything like that. Nothing. They're both fractions are simplified. They're very simple. And then we're just gonna just multiply them straight across. So 5 times 5 is 25. And 3 times 7 is 21. And it's an improper fraction, but yeah, that's the answer. That is the answer. Let's get another example. We have a whole number divided by a fraction. Now remember, I'm going to rewrite this as a multiplication of the reciprocal. And now I can go forward with this. There's nothing that can reduce or anything, so it's just straightforward. 2 times 2 is 4, and the 3 is just there. And that's the answer. That's just it. Let's go with this one. 10 over 9 divided by 6. Now, in this case, we're always told, right, in school, we're always told that a whole number, if you're going to write a whole number as a fraction, a whole number written as a fraction it's pretty much that number over 1. It's pretty much like that. So the whole number of 6, every number that's whole is pretty much over 1. So if you look at it as that, now it can help you visualize what should be next. We're going to write the reciprocal of that, and it's 1 over 6. Now by looking at this, we can do some kind of reducing or canceling before multiplying straight across, because I'm looking at this 10, I'm looking at this 6, and I see something going on there, right? I can see a greatest common factor of 2 between them. That's the greatest number, because the 6 is pretty much made up of 2 and a 3. 2 times 3 is 6. And this 10 is made up of a 2 times 5. So the 2's can cancel each other, right? Leaving the 5 and the 3 here. And so that means it's going to be a 5 times 1, and it's going to be a 3 times 9, which is 27. And then that's your final answer. 5 over 2 divided by, let's say, 4, right? Again, here's a whole number, because remember, we've got to flip that second fraction, and we have a whole number here. But every whole number is pretty much a fraction, which is that whole number over 1. That's every whole number. Every number we've seen in our whole life is pretty much that number over 1, but we just don't write it like that until now when we're really considering fractions. So let me rewrite this as this fraction times the reciprocal of the second fraction, and that's going to equal, okay, nothing to be reduced, so I'm just going to multiply straight across. 5 times 1 is 5, and 2 times 4 is 8. And so that is it. And if we introduce sign numbers, it's going to be the same thing again, right? Where with sign numbers, if the signs are the same, your answer is going to be positive. If your signs are not the same, your answer would be negative. So if this was like this whole this fraction's a negative 5 over 2 divided by 4, then it's going to be negative here times the reciprocal, and then we're going to have a negative times something that's positive. Answer is going to be a negative if that were the case. So the same rules apply as far as signs go. I'll probably just do 2 more examples with the signs. So remember, when we multiplying and dividing the same signs, your answer, no matter if the signs are both negative or both positive, your answer will be positive. But if we're multiplying and dividing opposite signs, your answer will always be negative. So if we have a 5 over 3 divided by 5 over 3, I'll just rewrite it like this, times the reciprocal. And just by looking at this, I can see they cancel each other out. All right, this 5 cancels with this 5. The 3 cancels with this 3. So pretty much this is going to equal 1. You have a situation like that, is 1, right? There's a 1 here, there's a 1 here, there's a 1 here, there's a 1. All ones, your answer is 1. Had this been negative divided by negative, then you're going to have negative here times negative. The answer is going to be a positive 1. Had it been a positive times a negative, then it's going to be a positive times a negative. And the answer will be negative because we have the multiplication or division, same thing, of opposite signs, unlike signs. And so that would be your answer. And if you keep that in mind, you just keep remembering that, you should be good. I think that's all for now. We'll see if I can get more examples, and that is it. Bye.